To solve a nonlinear system of equations by substitution. Your first move is to find an equation, the first one or the second one, in which you can easily isolate one of the variables. The easiest one to manipulate is going to be the first one because it has a y, it has no coefficient with it. So we can move that down here and do 2x plus y equals 5 and isolate that variable y. Leave it on the left hand side and move the 2x to the right and make it negative 2x and then plus 5. Y equals negative 2x plus 5. That means where you see a y in the other equation, you can put in negative 2x plus 5 in parentheses. So we'll go to the second equation, x squared plus y, and we'll put in negative 2x plus 5 and set that equal to 4. Now get rid of the parentheses. This is simply a plus 1. You're multiplying through by. So you can remove the parentheses without having to do anything else. X squared, instead of plus a negative 2x, is just minus 2x. And then plus 5 equals 4. You have to make this into a quadratic equation that has this form, ax squared plus bx plus c equals 0. We've been over that 3 times before for 3 different tests. So to do that, we'll go here and keep the x squared and the minus 2x and the plus 5 on the left, but we'll move this 4 to the left and make it minus 4. Set it equal to 0. Simplify those two constants at the end. Plus 5 minus 4 is simply plus 1. And once you get your quadratic equation set up, you have 3 options. You can complete the square, you can use the quadratic formula, or you can factor. In this case, it's easily factorable. 2 numbers that multiply to get a positive 1 and add to get a negative 2 would simply be negative 1 and negative 1. So it's x minus 1, x minus 1. These 2 numbers multiply to get positive 1, they add to get a negative 2. Once you do that, you set them both equal to 0, both expressions. And since it's the same thing, you're going to get the same answer, which you only need to write once. So x is simply going to be 1. Once you find your x answers, you have to take them back to the beginning, up here, and choose one of these 2 equations to put it in to find the y. So we can go up here to the first one. We can go there to 2x plus y equals 5. 2x plus y equals 5. Remember, we found x to be equal to 1. So we're going to put that 1 in where you see an x and solve for y. So 2 plus y equals 5. Move the 2 over, change the sign, and you come out with a 3. You put in a 1 and came back with a 3. So that is your answer. Now go back over here, since we don't have anything else to use for an x value, and just check with this equation. X squared plus y equals 4. X squared plus y, whoops, I put a 4, it should be a y, there we go. X squared plus y equals 4. And remember, we had x equals 1. So if I put 1 in here, let's see if it gives me back the same answer. 1 squared is 1. And then you're going to have y equals 4 minus 1. That'll give you a 3. So that does come out to be the same as the other one. We put in a 1, we got back a 3. You only have to write that once. And we just double check the other one to make sure we were right. This is the only solution. So we have to figure out where we're going to find a variable that we can get by itself. In the first equation or the second one? Which equation has a variable that we can easily get by itself? The first one. So on the first one, it is x squared plus y equals 7. Which variable can we get by itself? The y. So if we leave the y where it's at, we're going to move the x squared to the right, change the sign, and then have a plus 7. So that means y is equal to negative x squared plus 7. And where you see a y in the other equation here, you should be able to put in negative x squared plus 7 and be able to solve for x. Or not x, but oh yeah, actually it is x. So we're going to go here and use 2x minus 3 times this expression, negative x squared plus 7, and then set it equal to a negative 13. Get rid of the parentheses. You're distributing through by a minus 3. So minus 3 times a negative x squared is plus 3x squared. And then minus 3 times 7 would be minus 21. And you still have the negative 13. Don't forget you have to put this in the form that is ax squared plus bx plus c equals 0. So we already have a 3x squared and a plus 2x and a minus 21 on the left. We're going to move that minus 13 with it and make it plus 13. And then simplify those two constants at the end. A negative 21 plus 13 is going to be a negative 8. So you have three choices: completing the square, quadratic formula, or factoring. Which way would be the easiest to solve this quadratic equation? We could try factoring. What about the quadratic formula? We can plug it in really easy and do negative 2 plus or minus the square root of 2 squared minus 4 times 3 times a negative 8. All of that over 2 times 3. So simplify under the square root sign. You have a double negative here and here, so you're going to end up with a plus. So you have 4 times 3, which is 12. That comes from here. 4 times 3 is 12, times 8 is 96. 2 squared is 4. 96 plus 4 is 100. And then you can go down and make two problems. Negative 2 plus 10 over 6. And remember, the square root of 100 is 10. That's where that comes from. And negative 2 minus 10 over 6. So in the first case, you have 8 over 6. And in the second case, negative 12 over 6. That first one on the left simplifies to a 4 over 3. And then the other one is a negative 2. Back up at the top, we're going to plug in the values for x that we found into one of these two equations. Let's use the first one to see what happens. And that is x squared plus y equals 7. X squared plus y equals 7. And remember, the first thing we found was 4 over 3. So if I do 4 over 3 and square that, plus y equals 7, I'm going to come out with 16 over 9 plus y equals 7. And then subtract the 16 over 9 on the right side. Now if you do it on the calculator, fine. If not, then you have to do common denominators. The common denominator would be 9, so you would have 63 over 9 minus 16 over 9. And you'll come out with 63 minus 16, which is going to be a 47. 47 over 9. And if you change that to a mixed number, 9 goes into 47 5 times with 2 left over. So 5 and 2 ninths. So we put in what was 1 and 1/3, 4 over 3, and got back a 5 and 2 ninths. But we still have that negative 2 to put in. And remember, the equation is x squared plus y equals 7. So x squared plus y equals 7, and we're plugging in a negative 2 for x. And then solving. So if you square negative 2, you get 4, and move it to the right side, subtract, you will come out with a 3. So we put in a negative 2 and came back with a 3. So your two different answers are in the parentheses, here and here. Your first move here is to find a variable that you can get by itself. In both equations, you're going to have a minus y, so it does have a negative 1 attached to it. So in either one of these, you could get y by itself. You'd end up dividing by negative 1 at some point. I'm going to choose the top one. So we'll start with 2x minus y equals 6. You have to leave the minus y by itself, and I'm going to keep this as a very poorly written 2x there and make that negative, and then plus 6. But divide everything by negative 1 to make it a positive y equals 2x minus 6. This is equal to y. So if you come to this equation and put it in for y, it would look like x squared minus the quantity of 2x minus 6 equals 18. To get rid of the parentheses, we would have to use this minus sign and use it as a negative sign. Change the value of everything inside. So it's minus 2x plus 6 equals 18. And we need this form of a quadratic equation. And to get this, we already have the x squared minus 2x plus 6, but this must go to the left and change signs. And you must simplify the constants at the end, which would be 6 minus 18 being negative 12. At this point, you could complete the square, use the quadratic formula, or factor. This one is easily factorable and factors out to, we've tried to factor this one and it's not going to work out. So we'll use the quadratic formula to do a negative, negative 2 plus or minus the square root of the quantity squared of negative 2 minus 4 times 1 times a negative 12. All of that over 2 times 1. So we end up with a positive 2 plus or minus the square root of the simplification of that underneath. You have a double negative, so that's going to be a plus. This is 4. You're squaring that to get 4. And 4 times 1 times 12 is going to be a 48. And 48 plus 4 is going to be 52. So on the bottom here we'll have 2. Alright, so we're going to end up with a 2 plus the square root of 52 over 2, and then 2 minus the square root of 52 over 2. And you can solve that twice to come up with the decimal form. So 2 plus the square root of 52. So do 2 and then plus the square root of 52. Get an answer and divide it by 2. And this will come out to be 4.6, and we'll round this. And then do the same thing on the other side with a minus and get 2 minus the square root of 52. Get an answer and divide it by 2. And come out with a negative 2.6. So you have two answers for x. So 2x minus y equals 6, and we're going to plug in 4.6 to start with. So 2 times 4.6, subtract y equals 6. That would be 9.2 minus y equals 6. So 6 minus 9.2. When you simplify 6 minus 9.2, you should end up with a negative 3.2. And then divide both sides by a negative 1. So we put in a 4.6 and came back with a 3.2. Now you have to do the same thing for the other one. And that was a negative 2.6. So the equation is 2x minus y equals 6. And we're plugging in a negative 2.6. So that would be a negative 5.2 minus y equals 6, and then we have to keep this minus y, keep the 6, but add 5.2 on the right, and come out with 11.2, which we have to divide by a negative 1 to get a negative 11.2. So I put in a negative 2.6 and came back with an negative 11.2.